Hi, I'm Francis Campoy, and this is Just for Funk. Hi, and welcome to episode number 10 of Just for Funk. I am here today in Shanghai, China. I am attending Go for China, that's why I'm here. And I'm attending and speaking at the same time with Dave Cheney. So that is the guy with the slightly longer beard, actually way longer beard that you saw at the beginning of the video. He's an amazing golfer. If you don't know who he is, Google Dave Cheney, find a video, find some talks of him. They're really good talks, so go check it out. So today we're gonna continue with the same topic as last episode. 2 weeks ago, we discussed the context package, and we discussed the context package from the point of view of a user, meaning that I went over all the functions that the API offers, like background and to do, with cancel, with timeout, with deadline, and with, I'm forgetting one, with value. And I explained what do they do and how to use them correctly. So today we're going to be talking from the other side of the API. So rather than being the users, we're going to be the implementers. So the goal is to start from scratch, from simply package context. That's the only line of code that we're going to start with. And by the end, we should have a complete context implementation. Complete from the point of view that all the features are there, but it doesn't mean that the code will be exactly the same as in the standard library, because the standard library adds some extra checks and especially some extra optimizations that we will not cover, because otherwise this video would be way too long. By implementing this, I hope that you will gain a better understanding of how the context package really works. But not only that, I really feel that by implementing the context package, you're going to see some subtleties, things that you might know about Go, but you do not think about applying when you're writing code. Also, some really nice usages and patterns for concurrency using channels and Go routines for a thing that doesn't sound like it's a concurrency problem at all, but solves the problem so well and so elegantly. So hopefully you will learn all of this by the end of this video. Does that sound fun to you? Let's get started then. So before we start, today I would like to try a new way of coding. So on top of having my traditional VS Code open while I write code, you're gonna be able to see also on the right above me, which is your right side, I think, or left, whatever, right above me, you should be able to see this build failure thing. That is Go Convey. It runs your unit tests, like Go test, and it shows you the result on this beautiful web page. And every single time that you do anything on your code, when you save, you're gonna see that will blink because it's still not compiling, but it's basically monitoring the changes on your files and rebuilding and passing the test again. So I think that might help. On top of that, I also started by writing a bunch of tests. They're all commented for now, but at the end, we should have all of those tests passing, and that will help me a little bit guide the program. You could say I'm doing test-driven design today. Not really, actually, but you could say that. So with that said, let's get started by reading a little bit of the documentation of the context package again. So in the documentation of the context package, we can see that there's one type that is the main, most important type of the whole package, which is the interface context. And we need to define that. So since it's an interface, I'm just going to copy paste it directly. It's part of the API, and we said that we would implement the same API. So just going to copy this and paste it here. And I'm going to remove all the comments by using I've learned this not that long ago. Multi-cursors. I really like them. I think they're really cool. Okay, so we have this context now defined and our test pass. Why? Because we do not have any tests. So that was easy. So our first test is about background and to do. So what it does, it checks that first those functions actually exist and that they return two values that are different from each other. So we need to implement those. Let's say func background is context, and func to do is also a context. And let's say for now that they return nil. Let's see. It doesn't pass because it's saying, well, now to do and background, they do exist. So the test compile, but they're both nil. So that is not correct. So what we need to do is we need to return some value. Also, by returning nil, if we call anything, that would panic. So, not a very good idea. So what is the behavior we want here? If you remember from last episode, when you have the background or to-do context, they do exactly the same thing. They don't have a deadline. They don't have any values. Error is always nil because the context never finishes. Therefore, the channel returned by done will never be available for reading. So how can we do that? For no values, we return nil. For no error, we return nil. For no deadline, we return the zero value of time and false. And for a channel that is always blocking, we can return nil. That is exactly the behavior of the nil channel. And if you did not know about this, I recommend you go watch my talk, Understanding Nil, that I gave at GopherCon in Denver last summer, 2016. I'll have a link in the show notes unless I figure out how to add links somewhere around here. So, cool. So let's do that. And the behavior that I mentioned, I did not mention anything about the value itself of the context. It means there's no context at all. There's no value to it, right? So we can create an empty context. And we're going to say that's an empty struct. So to make this satisfy the interface, we need to say func context empty context, and why is this complaining? Missing return. Okay, so we said that we return nil for values, nil for errors, nil for the channel, and here we want to return the zero value for time and also the Boolean false. Since false is also the zero value for Boolean and these return values are named, we could use a naked return. A naked return is a return that does not mention what it returns. You can only do this when you have named return values. So here, their name, we have deadline and OK. And this is something that in general, I'd say you should not use. But I'm going to make an exception here because the code is so simple. It is literally just return. So it is not hard to understand what the code is doing. When you have a longer function, naked returns can be a little bit confusing. So it's better to avoid them. Okay, so let me make this a little bit more readable. Right now, it is not the most readable code. Also, because this is a very long font. Very big font. Okay. Now this is a little bit better. Cool. So we have our deadline, our done, error value, and we're going to return empty context here and empty context here. And our tests still fail because it says empty context equals to empty context. That makes sense because when you have two different structs and you compare them, as long as they're of the same type, of course, what you do is you go over all the fields, and if you find any of the fields that is different, then the structs are different. Now, in here, there's no fields, therefore, everything is equal all the time. So, how do we fix this? Let's try pointers, because, you never can have two pointers with the same value, right? Well, that is actually false. You can indeed have two variables with the same address when they are allocated one right after the other and they both have zero size. So in this case, our empty context is indeed empty. The size in memory is 0. So if you allocate two in a row, you will put them exactly in the same place, therefore getting the same pointer. So how do we fix that? Well, In the standard library, what they do is let's just not make it empty. So let's make it int. So now this does not work. We need to say a new empty context, and same thing here because they're not structs anymore, so you cannot use that syntax. Cool, and now our test pass. But I'm not very happy because before we were not allocating at all. And now every single time we allocate, we call background or to do, we allocate one more int. And this is not very good. So what I want to do is to allocate as little as possible. And there's a very nice way of doing it, which is defining two variables. Background, which is a new empty context, and to do, which is a new empty context. And then you return this here. Whoops, to do. And now the good thing about this is that not only you avoid having extra allocations, you will only allocate 2 ints ever for empty context, which is nice. But on top of that, if you have 2 different backgrounds, you can check them and make sure that they're equal, which means that if you were to define a string method, that string method could use that, could do, well, is this the value background, then print background. Otherwise, is this the value to do, then print to do, which is, pretty useful. Awesome. So now we have empty context working, which means that to do and background are implemented. So let's go with the next step, which is going to be implement with cancel. First things first, let's make our test fail by adding this one here. There you go. It doesn't compile. This one is testing with cancel, and with cancel still not defined. So we're going to need to define it first. And if you remember what it looked like from last time, basically it's a parent context. It returns a context and a cancel func. And that cancel func is simply an empty function. It's an empty function, a function that doesn't receive any parameters, doesn't return anything. Why do we even create it as a type that we export? Well, because that way we can document it. It is that simple. So what is the behavior we expect from a context that we return here? Well, value, it will return whatever the parent returns. Deadline, it will return whatever the parent returns. For error, it will return nil until that cancel func is called, and then it will return canceled, which, by the way, we should define. If we go var canceled, there you go. Let's copy that and put it also here. So we have our canceled error that will be returned, and then also we have done, and done will return a channel that will be closed when cancel func is called. So what do we need to do that? Well, we need to keep track of all of those things that I just said. So a cancel context will have a parent context, we'll have a done channel of empty structs, and an error. And we're going to define that. Actually, something that I like to change is the fact that we have this context here, and we don't even need that because we're not using it at all. So you don't even need to name that receiver, making it even more obvious that empty context is not important. That integer doesn't change any behavior. Okay, so next, what we need to do is we need to implement with cancel. So with cancel, we'll create some context with cancel context. The parent will be the parent. That is easy. Done will be a new channel, and error will be nil, so we don't even need to do anything there. And then we'll return that context and a cancel func. And that cancel is a function, as we said before. And what does this function need to do? Well, when it's called, it should set the error to canceled. So context.error equals canceled. And next also should close context.done. Cool. This is not happy. Cancel context. Ooh, because we need to define all of those methods on cancel context. So let's do it here. Cancel context. Let's define it on the pointer. Why not? When deadline is called, we need to return the deadline of the parent. When we call value, we need to return the value of, the parent, value of key. When we return error, so we return context.error, and here we return context.done. And here it's important to pay attention to one little detail, which is the fact that we return context.done, which is of type a channel of structs. So by default, if we return that, the person calling this function could close that channel or could even send things into this channel, messing up with the whole implementation. But we avoid that by simply having this little arrow right here. By the way, people keep on asking me about this font, and I don't know if I should stop using it. This fire cut with ligatures. This is simply the less than and a dash, and it makes it look like an arrow. It is not an arrow. It's just simply through those two characters. I like how it looks, but if you feel it's very confusing, let me know and I will change it. It will hurt me, but I will do it for you people. Anyway, the important thing is that by adding this little arrow here, what we're saying is that the channel we return can only be used to receive from, not to send things into, and especially not to close it. So we're adding that extra security here, which is very important in this case. Okay, so our test still does not compile because we need to return a pointer receiver. There you go. Okay, so now our test passed, which is nice, but I am not completely happy with this code. So there's something wrong. I don't know if you're able to tell what could be wrong in this code. If not, the name of the next test is test with cancel concurrent. So now that's a little bit of a piece of information that might help you figure out what's wrong. But the test passes. And it passes because GoConvey is a great tool, but it has a big lack, in my opinion. It's missing the fact that you can run it with the data race detector enabled. So let's stop GoConvey and run go test-race, and you will see that there you go. You get a data race detected. And it's saying that the data race is between context line 52 and context line 38. So context line 52, context lines 38. So it's between rewriting, and rereading error. So yeah, that is the problem. We can do this from different Go routines, so we're accessing the same variable and we're not protecting it. Therefore, we have a data race. How do we protect this? Mutexes. So syndoc mutex, and now error is gonna be a little bit longer than before. So we're gonna need to first lock it and then unlock it at the end. And similarly, we're gonna do something similar here. There you go. So with this, we should be able to run the test again. And now it should pass. There you go. So important, run your test with data race enabled always. Okay, there's one more piece of code that I'm not very happy with. And if we go back here, you're gonna see which one I'm talking about. It's the fact that deadline calls context.parent.deadline and value calls context.parent.value. And there's a nice way of making these two lines disappear. Which one? Well, it is as simple as using inheritance. No, not inheritance. There's no inheritance in Go. We're going to use composition as we're doing now, but we're going to do composition and we're going to proxy the calls that we have not defined from our cancel context to our parent context. To do that, we use struct embedding, and it looks as simple as dropping the name here. Now, when that context does not have a field name anymore, our field is context. So these should be context, this should be context, but the whole point is that now we can drop these 2 lines. They're not needed anymore at all. They're now implicit. And here, though, we're going to need to name it. So we're going to call it context. That is the name of the field. And our code now is a little bit simpler, which, it's always nice. Cool. So the next step is one more test. What is the next test? Test with cancel propagation. Okay, so now we run this new test and it says timeout error should be canceled now, and it was not canceled. What this is testing is the case where if we have a context, there is a cancel context, and then from there we create another context and it's also a cancel context. When we cancel this one here, the one below should also get canceled, right? And we are not handling this at all. So how could we do this? There's a couple of ways. One of the ways is, well, for every single cancel context, we need to keep track of all the contexts that are below. So whenever this one is canceled, then we can call cancel on all the other ones below. Couple of problems with that. The first one is, well, if we keep a list or a map or whatever of context, the context interface does not have a cancel function, so we cannot really do that. We could be able to do it if we're able to figure out that there's a cancel method, private, non-exported, because we are part of the same package. But then what happens with the package, with the context that other people implemented that do not have a context method? Little bit of a problem, right? But there's a much easier way of doing it. And this is the part that really got me excited about the context package. I think it's a beautiful way of handling the cascading of the cancellation. So how do we do it? What is the best thing that we do as Gophers? Concurrency. And we have Go routines, and we have channels, and we have select statements. And with those 3 things, we can write an amazing piece of code. I think it's like 4 lines of code that will handle cascading of the cancellation very easily and simply. So what we're going to do is we're going to go here, and before we return this function, we're going to create a new Go routine. So that's a new Go routine that we're calling here. So what it's going to do is going to check for parent to be done. And once parent is done, it will cancel the context we're returning. If the context we're returning is the one to finish first, then we would just drop our Go routine. Why? Because maybe parent is background. Who knows? And that will never finish. So we don't want to leak Go routines. So what does this code look like? We want to do 2 things at the same time on different channels. That is a select statement. The first one is the case where the parent is done, in which case we need to do pretty much the same thing as in here. Except that I'm going to move this here. And I'm going to set the error to the error of the parent, not the error canceled, because there could be something different that made the parent finish. And if the case is the context is done, then we just finish. We don't do anything extra. Cool. So now this code not only doesn't pass the test, but it actually panics. And it panics saying close of a closed channel. Okay, so what's going on now is that this close is being executed twice. And there's 2 ways we can call that. One is the parent finishes, and the other one is we call cancel. Now, this will happen that cancel is called more than once. And this should not be a problem, but now it is. So how do we do it? Well, we need to check if the channel is closed, and if it is, we should not close it. but that is kind of hard to check if a channel is closed. There's ways of doing it, but I'm not gonna be covering today because there's a much easier way of doing it, which is simply checking if the error is nil. If the error is nil, the channel is open. So if context.error is not nil, then we don't do anything. And similarly here, if context.error is not nil, we don't do anything. And now our test pass. Now, what I'm going to do next is I'm going to move all of this code to a different function, cancel context, that I'm going to call cancel with an error. And that will do all of these things, but setting this to be error. So this function will simply say cancel the context with the error of the parent. And this one here will say cancel the context with canceled as the error. Cool, so our test is now passing. So we have background to do with cancel done. We have 3 more to go with timeout, with deadline, and with value. And those 3 are actually way easier to do. So I'm going to start by, again, adding 1 more test and seeing it fail. This test is checking with deadline. So let's implement that one first. So with deadline is very similar to with cancel. There's a parent context, but also a deadline, which is a time, and it returns a context and a cancel func. What we want to do is we want to cancel that context after a given time, which, looks exactly like a cancellation context. So let's start with that. I'm going to create a with cancel from the parent. And that will give us a cancel context and then also a cancel func. And we will return cancel context and cancel. Actually, not really. But we'll return, well, actually, let's start with that. So what we need to add on top is the fact that that context should be canceled after some time, whenever the deadline arrives. So we can do time after func. The duration that we need to wait is time until deadline. And then we're gonna call cancel. Cool, and our test doesn't pass because, deadline exceeded is not defined. Deadline exceeded is 1 more error. So let's add it here. Deadline exceeded is deadline exceeded. Okay, so our test now compiles, but it does not pass. It does not pass because say that the deadline expected was someday, but it got 0. Why? Because we're not storing that deadline anywhere. So that is why we actually need deadline context that has a cancel context and also a deadline, which is a time.time. So let's get those 4 methods from here again, and let's make deadline satisfy all the interfaces that we need. So context is a deadline context, and it does something. Now for deadline, it will return context.deadline and true. For done, it should return whatever the parent says. So return context.parent.done. Here return context.parent.error, and here return context.parent.value of key. And as I'm sure you're already expecting me to do, what we're gonna do is we're just gonna drop all of these and simply do struct embedding again. So now we have this, which looks pretty good. It's still not passing because now what we want to do is we want to create our context, which is a deadline context. And the cancel context is going to be cctx. And our deadline is going to be the deadline. And we're going to return ctx. Now this says, well, you cannot really do that because you have an interface context and you're trying to use it as a concrete type. But in this case, we know that that is always the case, right? With cancel, always return a pointer to cancel context. We could, if we really wanted to make this clean, we would define an extra function that returns a pointer to cancel context, and they both with deadline and with cancel call the same function. I don't care that much, so I'm going to simply do this type assertion and say I want to use cancel context as a cancel context because I know it is a cancel context. Cool. Our test doesn't pass yet, but it passes a little bit better. It says, okay, the error should be deadline exceeded, but it got context canceled. Why is this? Because after the given time, we cancel the function and that will set it to cancel. So what we want to do is instead move it here and call context.cancel of deadline exceeded. Is this correct? Oh, this should be a function. So, okay. So after some given time, we're gonna call cancel passing a deadline on context, and now everything passes. The next test is with timeout. And with timeout is incredibly simple to implement. So everything we need to do is with timeout, it's gonna have a timeout, which is a duration. What we're going to do is we're going to return with deadline of the parent and time now and add the timeout. That's it. So now what we're doing is we're saying with timeout should return the same thing as with deadline, and the deadline is from now plus the timeout. Simple. Totally makes sense. Okay, cool. This is pretty good, but there's a couple things that I do not like. There's, in the documentation of context, you could read the fact that the cancel func needs to be called regardless of the context being canceled or not, because it needs to release something. And we're not releasing anything here. What could we release? What do you think, what kind of things we could stop? Well, we have time after func. Imagine that we say the deadline is in a year. We do not want that Go routine to be waiting there forever, right? We would like that to be canceled as soon as we cancel it. So how do we do that? Turns out that time after func returns a timer, and that timer has a method stop. So what we want to do is whenever this cancel function is called, on top of canceling the context, we should stop that timer. So first things first, we need to keep track of that timer. And then what we're gonna do is we're gonna have a new function that we can actually reuse the same one. Let's not, because it makes it a little bit more complicated. But stop is gonna be a function that stops the timer and also calls cancel. And that's what we're going to return instead. So now what we're doing is whenever stop is called, we will stop the timer and then cancel the context. So everything will work and we will release all the resources that we need to. Awesome. So we have to do background with cancel, with timeout, and with deadline implemented and tested pretty much. We only have one left with value. Let's do it. Cool. So one more time, we're going to start by removing the comment and adding one more test. And that test should normally fail. Okay, there you go. It fails because with value does not exist. Let's define it. So with value given a parent context, and a key and a value, which are empty interfaces, returns a context. So we're gonna need a new context, value context, which is gonna keep track of the parent, which I'm just gonna do struct embedding directly because you know that that's gonna happen. A value and a key, which are empty interfaces. So what we need to do is we need to return a value context that has context is parent, key is key, value is value. And we're done. But no, we're not. This should compile. I think. There you go. It compiles, but it doesn't pass. And it doesn't pass because it says, well, I expect the value B and I got nil. Why? Because we did not implement value, which is the only important one. So, okay. Context, value context. We need to do value that given a key, which is an empty interface, returns an empty interface, which is the value. It's past pointers because we've done that everywhere. So out of consistency, I think it's better. So if the key equals to the key that we have, we return the value. Otherwise, we return the value that we find on the parent, which could be none, but that's fine. So we're basically going up the tree. And with this, our test compiles, but it does not pass because expected value nil and got true. Oh, okay. So we have a couple problems here. So even though now our code for our library is technically correct and it does what we want, there's a little bit of an issue because it is very permissive. It allows you to do whatever you want to, and there's things that you should not be able to use as keys. One of the things that we do not want to do, for instance, is to allow nil as a valid key, because that could be very confusing and could cause bugs. And you will realize that those bugs are there way too late when you do get of nil and you get some random value, right? Not a very good idea, so it's better to panic as soon as possible. So we're gonna check if the key is nil, panic, key is nil. And that should make my test pass a little bit more, not completely, because there's one, whoa, my test passed, that is wrong. Okay, it should not pass, and the problem is that what happens if we have another test where what we're doing is we're passing a key that is of a type that is not comparable. And that is a thing. Keys that are types that are not comparable exist, such as, for instance, slices. You cannot compare two slices. You can compare a slice to nil, but you cannot compare a slice to another slice. That's not a thing that Go allows you to do. So how can we check that? Well, there's actually a very simple way of doing it using the reflect package. So if reflect type of key is comparable, I'm almost sure that is correct. So if it is not comparable, panic, key is not comparable. There you go. And with this now, we're able to also check if you try to pass an empty slice, well, actually any slice, it will fail saying that is not a good key, and it will fail right there, giving you the panic on the call that actually causes the context to get a value that is not allowed, rather than having issues whenever you try to retrieve that value and we actually compare one slice to one slice, and then there it will panic. So it requires a little bit of reflection, but it makes our package much nicer to use for our users. Cool, so this is the end of the video. Our context package is fully implemented. I hope that you learned something on the way. I definitely did learn a lot by implementing the package. I gave a talk about it at GopherCon India, and I will have a link to that talk in the description. Thanks so much for watching, so many of you, the previous episode on Context 2, episode 9. And as always, one little favor, subscribe. Thanks for watching.